Okay, so our problem today involves two circles. One has a radius of 13 inches, and the other circle has a radius of 7 inches. And the centers of these circles are 29 inches apart. What we need to find is the length of the internal tangent line, which I've marked with this green line, though I have extended it a bit past each side. Lots of people don't understand what an internal tangent line might be. It's a couple of big words. So all that an internal tangent line is a line that goes in between the two circles and is tangent to each one of them at a single point, which I've marked with black dots. So how we're going to go about doing this is really just add some more lines, try and see what we can figure out until we have something we can work with. Because right now we don't have any measurements we can really figure out or make, or anything we can really give a value to. So I'm going to start by extending a line from the radius of this circle to the tangent line that'll be perpendicular to that tangent line. So that makes a right angle. I'm going to continue to extend that line to help us visualize things later. And I'm going to do the same thing over here. I'm going to extend this line, I'm going to extend a line from the center of this circle to where the tangent line hits this circle up here. And extend it all the way down as well. And again, this right here is a right angle. So what we're going to look at next is making a line that is parallel to this green line. Because this green line here, our internal tangent line, is perpendicular to this line here and this dotted line over here, I'm just going to extend a line from the center of this circle all the way across to hit here. And I'm going to say that this line is perpendicular to that one, which means it's also perpendicular to this one. Now, if we look closely, we can now see a triangle. This triangle extends from the center of this circle down to this right angle, all the way over to the center of this circle, and then across the hypotenuse back to our first circle. Now, we actually know some more values on this line than we might think we do. So we know that this line segment here is the radius of this circle, which is 7 inches. We know that this line segment here is 29 inches, and we know that this line segment right here is 13 inches. And that's in between this line and this line. And if you take that all the way down here, since these lines are parallel, that means that this line segment over here is also 13 inches. 13 plus 7 is 20 inches for the length of this line here. So because we now have 2 of our 3 sides, we can find the last one using the Pythagorean theorem. So I'm going to assign each side a letter. This one will be A, so A equals 20. B, we don't know yet, and C equals 29. That means that A squared plus B squared equals C squared. So A is 20, so 20 squared plus B squared equals 29 squared. 20 squared is 400, so 400 plus B squared equals 841. We subtract over our 400, take the square root, and we find that B equals 21. So I'm going to put that back in our diagram over here, and we're going to look back at what we have. So we've actually made ourselves a rectangle inside part of this triangle. So this right here, from this point to that one, That's a rectangle because all of our corners are right angles. So that means that the length of our internal tangent line right here is equal to the length of this leg of our right triangle, which we just found is 21. So that means that the length of our internal tangent line is 21 inches.